URISA NG9-1-1 Task Force webinar on digging a little deeper, ETL for NG9-1-1 GIS data. The task force tries to do webinars about quarterly in a mix of conversations about lessons learned or ask the experts or different things. And we thought it would be good to have a little bit more of a technical focus. And where the inspiration for this comes from is that ETL is a very common, but not always well understood part of the GIS toolkit, because there's so many options and there's so much flexibility with it. But the NENA GIS data model does have this expectation, and it's quite clear that you don't have to change all your data to match this data model, as long as you have the ability to export whatever your local GIS data is into the NENA GIS data model or whatever your next generation core services provider or spatial interface provider expects. So we thought it would be a good idea to tackle this in a webinar and talk about some of the umbrella terms and some of the concepts, and then demonstrate them with actual locality data in the actual NG9-1-1 GIS data model. And so we're happy to have so many folks on with us today, and we hope that this will be useful and good content, and that I will not regret my decision to volunteer for doing a live demonstration of GIS. So to get us started, I'm Matt Garricky. I work with URISA, with the Professional Education Committee and the NG9-1-1 Task Force. My day job is with the Virginia Geographic Information Network. We are part of the Commonwealth of Virginia government, supporting localities, PSAPs, and GIS, and the efforts to meet a legislative mandate of NG9-1-1 systems by July 1st, 2023. And here to help us out is Jeff. And Jeff, I'll turn it over to you.
Great, thanks, Matt. Hi, my name is Jeff Ledbetter. If you don't know me, I am a public safety GIS expert for the DataMark team of Michael Baker International. I've spent the last 10 or 12 years in 911 and law enforcement fire operations centers, figuring out how to apply GIS technology in a way that is beneficial to public safety emergency responders. And NextGen 9-1 GIS is my jam currently. So I'm glad to be here and talking about this topic with everyone. So if you want to go to the next slide, Matt. Actually, I'm going to turn my camera off so I can save my bandwidth and everybody can hear me. Of course, we're talking about with an extra ETL. That's a term that is often bandied about, but sometimes not fully understood what we're even discussing. ETL, short for extract, transform, and load, is defined as a process that extracts, transforms, and loads data from multiple sources to a data warehouse or other unified data repository. Now, that's in the broadest sense of the term, but specifically for Next Generation 9-1, it is a process that would extract from a local maintenance GIS data source, transform from the local maintenance format into the NG9-1 format, and load into what eventually will become a spatial interface and move into the next generation core services of the emergency call routing function, location validation function, IMSAC conversion service, and other various things that, depending on your provider, may be loaded up into other places as well. So if you'll move on to the next slide there, Matt. I want to talk with you about some of the general concepts, as Matt said, and then he's going to really do a great job of demonstrating some practical application that he's used there in Virginia. But in terms of the mechanisms that are taking place here, there are these extracts can happen not only from a maintenance schema, but maybe multiple maintenance schemas. In the next generation 911 context, we're talking about road center lines, we're talking about address points, we're talking about PSAP and emergency service boundaries. Those may be stored or maintained in different databases by different local data providers. There also is an aspect in which you may have multiple databases where if you are maintaining the GIS data for a county, you have to also collect it from your constituent cities. You may have all of your road center lines, address points, and boundaries in one geodatabase, but you may have to collect them from your constituent cities that have them in maybe multiple databases each, or simply multiple cities worth of data to extract. And it is this transformation is where things get a little bit sticky and a little bit tricky. There is sort of an initial reaction to the idea that among local GIS data providers that I'm going to have to change my schema to meet the NextGen 9-1 schema. Well, what if that breaks my asset management system? What if that breaks my permitting system integrations? What if that breaks my financial billing system integrations with my current GIS schema? ETL to the rescue, right? If you can extract from a format that works for those systems, you can transform into a format that is compliant with the next generation 9-1 GIS data model, and therefore can be provisioned into the spatial interface and on into those other next-gen core services. Now, what is a transformation? A transformation can be any change in the data. Sometimes there's schema changes, things like field widths, things like data types. You may have something that is numerically managed in one database that needs to be a text field in the next generation 9-1 GIS data model. You may need to normalize data. That is to say, all of your abbreviations, of course, in the next generation 9-1 GIS data model calls for things to be spelled out, but that's exactly a good example of, may not be normalization, but the data has to be changed and translated from the abbreviation of AV or AVE into the word AVE in UE, avenue. That normalization or data trend mapping has to happen every time you export an updated data set. This transformation stage is a great place to do some validations against those transformations, to check and make sure that the transformations that have occurred have not caused other violations of other data quality standards or rules that might need to be in place in the next generation 9-1 system as well. So this transformation is really where the motion occurs. So you extracted, you transformed it, now you load it into a target database. Is that a new target database every time? Is that a target database where we're doing change detection and only updating changes? Those are all questions that everybody has to answer for themselves as they construct their own ETL process. And how do we accomplish this ETL? It could be manual, could be that every time you're extracting by tools in your desktop GIS product or your server GIS product, that you're creating a new schema in your desktop GIS and pouring that data into it, that you're making transformations and validations that we've discussed all in your desktop GIS product with your mouse clicking at every step. But because typically these processes are repeatable and definable, they are ideal for automation. And if you're going to extract one of these or create one of these data sets on a regular basis, instead of doing it all manually again and again and again, introducing many points of failure, automate those changes to the extent possible. Now, sometimes you may not be able to fully automate it, but semi-automated processes are better even than manual automated processes. Here's a good question in the chat. Do you have to purchase ETL? That's a really great question, Callie. I appreciate you asking it, because ETL is really a very general term. It's not a specific software. It's not a specific product. And the point really that needs to be made in this conceptual section here is that the ETL that you need is the ETL that does exactly what you need done to your data. So the ETL that works for somebody in a similar seat probably isn't going to do everything that you need to your data. So you need to do what I refer to as a thoughtful interpretation of how to apply the NENA schema and the GIS data model requirements to your GIS data from their multiple or singular data set, source data sets. And you could do this in many different ways. Matt's got some great examples of how he's done it. But you can do this with Python. You can do this with any kind of automation tool. If you're less of a programmer and more of a GIS analyst type, you could use Model Builder in Esri's platform and similar tools that are in other open source platforms as well to simply automate repeatable processes. Now, this idea of semi-automation takes place in the same sort of container where you may have chunks of it that are automated, but with some manual just checking and validation, verifying, things like that in between. So there's many ways to accomplish the ETL. It's more of a general concept, and no, there's not like a product to buy necessarily that is required for it. Now, there's lots of products that you can buy that may help you along the way, may help you in that automation, may help you in the validations, may help you error checking and double checking that things got done right. But if you want to, you don't have to. You move on to the next slide there, Matt. So why is this ETL process useful? The whole point of it is to increase efficiency through automation where possible, to improve data quality while transforming. This is really a key step in my estimation, a key opportunity, because especially if you're bringing in data that you haven't been maintaining, you don't have the ability to trust that it's up to the data quality standards that you need in order to fulfill the next generation 9-1 requirements. And so ETL is an awesome opportunity for you to do those validations for data quality, find out where the data doesn't meet data quality that you need, levels of data quality that you need, and adjust those data sets or push them back to their data owners in order for them to adjust them. Thirdly, it enables non-technical data users, and this is a great thing about it as well. In some ways, it democratizes automation, because you may, if you engage someone who's capable of creating this ETL process, of automating it to the extent useful and possible, then you don't have to necessarily be a programmer to run it. You just push the button and then follow the instructions of QC quality checking the outputs to make sure that the desired outcome was achieved, and you can move along. So you may be a data analyst, a GIS analyst, and not necessarily a programmer or somebody who's great at writing Python. But if you find the person in your organization or somebody who help you who is that, then you can be that sort of non-technical data user, GIS analyst, and get these ETL processes completed appropriately. It also allows for the automated creation of metadata. Now, I know GIS people, they freak out a little bit when they hear about this data about data. They cringe a little bit and say, oh, that's so much work to do. This ETL process is a great opportunity to really mark where the data came from, when it was gathered, how it was processed, what the outputs were, what the old schema looked like, what the new schema looks like, what kind of transformations occurred throughout this process, and then automatically write it into the metadata of the geodatabase before it moves on to the next stop. There's no better way to create metadata than that sort of automatic data calling that happens. And because of all of these factors, this supports data governance really well. I already referred to an example of where somebody may need to send data back to a data owner because the data did not meet the levels of data quality required by next generation 9-1-1. So you may need to send it back to the data owner to be reprocessed or some way edited before it can meet the quality standards. this ETL process can also be sort of integrated into this data governance structure, so that when things come out of the ETL process, along with them comes sort of a report or some sort of indication. It even could go in the metadata of who owns this data, who's the right contact person, who's the data steward, how did it get processed into the format it got processed into. So this is another step along the way in sophistication of data governance process can be supported by these ETLs. Next slide. There's always, as always, and anytime you're designing processes, you have challenges with them. In this ETL process design and build phase, especially, and the execution phase as well, you may find that there's geospatial challenges. And what I mean by that, particularly using NG9-1 GIS Data Model as an example, what gets loaded eventually into the NextGen core services is going to be in WGS 84 coordinate system. Now, when you transform something that's maintained in state plane coordinate systems, it's an inevitability that you're going to transform, and you're going to introduce some error. You're going to kind of warp a little bit of positioning. And so even though you don't need to load that WGS 84 data into the spatial interface, you can load that state plane coordinate system data in there. In most of them just fine, all the ones that I'm aware of at least. And it does the transformation for you. You really have to take the opportunity to build a culture of quality assurance that would encourage folks that run these ETLs to maybe make part of that semi-automated check and validation of the ETL outputs to go ahead and transform into WGS 84 on occasion, do some spot checks, and make sure that the introduced error is sufficiently accurate, if that makes sense. That the transformation moves things, we know it's going to move things, as long as it doesn't move things too much or in the wrong direction, we're okay. You also have a lot of challenges when you have apples to oranges transformations. And what I mean by that is you have data that's built for, say, permitting systems around address points, or maybe parcels. Maybe your address points come from parcels. The data is built for those purposes, but you're really shifting the purpose in Next Generation 9-1 and asking it to do things differently and with a higher level of accuracy, perhaps a higher level of completeness that the other system required. And so you have to do some transforming in order to do that. You have to do some, there will be some assumptions involved in some of that. And so that's where some apples to oranges challenges occur, is that you may know that a certain transformation will work for 98% of your data, but you're going to have to dig into the 2% that it won't work for and work it out, right? Iron out what you're going to do for that. And that's where the idea of a semi-automated ETL becomes very attractive, because you can take advantage of the automation for the 98%, but then you may still need to do some manual work on that 2%. Source data sets aren't always aligned, and this is something of a similar concept to apples and oranges. Because it was built for pavement management systems, perhaps, it may not be aligned in terms of schema. It may not be aligned in terms of how the geometry is captured, what the geometry is intended to convey, the level of precision at which it is captured, and is that sufficient for NG9-1-1? So you want to pay attention to the alignment. How close was the alignment of the source data set to what I need it to do in Next Generation 9-1 GIS Data Model as well? So this may create intermediate data sets that have to be managed, and that's okay. And especially if you get it wired up and fired up into a fully automated process, that automation can handle those intermediate data sets for you. But be aware as you start to explore that if you use one analysis tool against it, it'll create an intermediate data set that you use again with another analysis tool, that there will be these intermediate data sets that if you don't handle and manage them properly, they may confuse you, and you may wind up sending on into the spatial interface a data set that really wasn't ready to go in there, but in fact was intended to be put through more analysis, more transformation, more changes before it got into the spatial interface. So those are just some challenges that you'll want to be aware of in general as you begin to define your process and refine your process and build these ETLs for next generation 911 GIS data. Thank you, Matt. What are the 911 implications of this? This allows GIS professionals to maintain a master data set with multiple outputs. Now, what I mean by this is there's a lot of variations to this, but one general concept is that instead of having a road centerline data set for your asset management system, an LBRS perhaps, and a different road centerline data set for your public safety systems, if it's possible, and it's not always possible, but it may be possible to bring those two together, right, to represent the geometry of an LBRS as well as the data that needs to go into a next generation 911 call routing system. Now, depending on the particulars of the needs of the LBRS, the particulars of where this is at, how many data sources come in, what are the quality level of the source data sources, how well aligned are they, this may or may not work for you, but the concept is out there that you could create a master data set, right? You have a master road center line that is geometry for many applications, including asset management, including pavement management, including transportation and general cartography needs, including the CAD system in the 911 center, including the next generation 911 call routing system. Have them all be in one geodatabase and have a set of a particular ETL for each one of those outputs that makes it what it needs to be for those particular consuming systems. This requires the support, again, of a culture of quality assurance. You want to build a culture that's concerned about data quality, and in fact, it's baked into every process that occurs. Particularly when you start automating things, if you're missing that culture of quality assurance, it's easy to kind of get complacent, fall asleep on the job. All of a sudden, you've got data that's not meeting the quality needs or the quality definitions that it needs to meet, and it becomes a problem. And then for the next generation 911 or even the CAD data sets that reside in the 911 center, those problems could potentially become life-saving problems. Problems of delayed response in emergency situations, and none of us want to be responsible for that. This also introduces a need for new quality control policies and procedures. It may introduce the need for some new tools, but it may not. There's a world of options out there, and lots of professionals that are doing it, as Matt will show us his examples of taking this data from multiple data sources, putting them through extracting them, putting them through transformations, and then loading them into next generation 911 call routing systems, loading them into CAD systems, et cetera, et cetera. So there's many opportunities with these implications, many opportunities with these challenges, but all in all, I'd love to hear from Matt, but something that I recommend to clients everywhere is that where possible, automate your processes using this concept of an extract, transform, and load process. So this is where we'll hand it off to Matt, and he'll take us through some of his great examples.
All right, thanks, Jeff. So what we do in Virginia is that we have, that changes my numbers. We have about 100 different provisioning polygons where there are 100 different localities or contractors working on behalf of a locality that are going through this process. And so one of my jobs and the folks I work with is supporting localities as they do this. And so we talk about this quite a bit. Some folks switch out their data model. Others are much more concerned about breaking other things they have going on. And so ETL is the right path. And so what we wanted to do today is just kind of talk through some examples. I will, over the course of the demonstration, talk about the tools versus models versus coding versus scripting, and kind of show some steps about manual, semi-automated, and steps that you could take to fully automate it. And going to try to approach it from two different areas. One is that extract piece, starting with a master data set and getting the spatial extent of just what you need to upload, just what's in your provisioning boundary to upload, and then some of the particular transform and load. And sometimes that's a little bit hard to draw a line, depending on what you're trying to do and how you're trying to do it. And so it's much more of a philosophical mindset, perhaps, than a step-by-step thing, because what works for you may not work for somebody else. So generally, what we where do I want to start? Let's start here. So here is a locality in Virginia. They've given me permission to use their data. I have anonymized their data a little bit, but I'm thankful for the support of the localities that I work with, and using some of their data for these purposes. And so what I want to start off with here is down here I have a local data section. And so we have address points, road center lines, and their ESZ boundaries that are going all over the place. This information is from their CAD system, the GIS data that they use for their CAD system. But our area of interest here, we use green for the PSAP polygon and blue for the provisioning polygon, is the area that they're responsible for provisioning, sending up into an NG9-1-1 spatial interface. And so the challenge for this locality is, I got all this other data I use for business purposes, business practices, CAD map display, but I can't upload that. So that first step is extracting just what they're responsible for extracting. And then we'll kind of shift and talk about, well, how do we get it into this target schema? And the format that it needs to be in to make it align a little bit more closely with the NENA data model. So let's start with the extract. For the purposes of what we're going to step through today, we're going to focus on road center lines, but at the end we'll come back and we'll kind of show what it may look like if you did it for the other steps as well. And if we have time, we can chase down some of those rabbit holes. So there are probably three common ways to do extract, to make a copy of the subset of the data that you want to work with. Before I start, I'm showing this to you in ArcGIS Pro. This does not constitute an endorsement of ArcGIS Pro, nor Esri product, nor any other Esri product. I'm showing it in Pro because it's what I use and what I'm familiar with. But you could just as easily do it in QGIS, and some of the other open source GIS platforms, and Blue Marble's products, or even Surfer would support it. A lot of the functions and tools that we talk about doing and using and applying to ETL, they're common. Any good vector GIS data software package is going to have them. So just put that up front. Okay, so one of the most common ways to think about this is select by location. And so if we want to select on our road center lines, and we want to use that against our provisioning polygon, the footprint, the cookie cutter of what we're responsible for in NG9-1-1, select by location is one of the ways of getting at that and thinking about that. Always check your inputs before you tell it to do something. It's like, wow, that went off the rails really quick for a live demonstration. but you can see, based on what's highlighted here, that sometimes select by location doesn't always work well for your data. Some folks edit their road center line so it snaps to the provisioning boundary. Some want to do that long term. Some haven't done that yet, but that doesn't necessarily solve our problem with this. Sometimes tweaking the method of select by location doesn't necessarily help us out either. If I select my completely within, if we pick a different thing, we may pick some, but not all the pieces. And so select by location, if that's the right tool, it really depends on how your data is structured. Some folks use select by attributes. Some folks will go through and they'll add a record, or they'll know they'll have an attribute in their road centerline data that codes, I'm responsible for sending this, or this is my neighbor's. And if you go through and you code your data that way, or you know you have an attribute in there that you can use that, you could select by attributes, pull out those layers and have that subset. If you use either select method, either interactively or programmatically, you tend to have to do something else with it. You're going to have to export it, save it as a copy, or do something with it. And so it kind of makes it a little bit more clunky in an automated fashion. I know that this locality doesn't have their attribute data structured that way. And so that select by attribute won't work here, but it may work for you. What works really well for this particular example is a good old-fashioned clip. We know that we have our road features. We know that that provisioning boundary kind of serves the purpose of the cookie cutter. And clip is a cookie cutter. And so if we go in and we run that, give that a second or two to run. That clip process, and I'm going to turn off my local data and just leave this work. All right, I am back for audio. Of all the problems I thought I would run into, I was not expecting that problem to happen. So with the clip we see here, it's only taking that subset within the provisioning boundary, and so that works out really well in terms of an extract, just copying out that subset and putting it into a different data layer. Clip is also really easy to work with in a programmatic or automated fashion. One of the things that you can do in Pro is if you run a tool, copy the Python command, or here I'm just going to send it down to the Python window, and we'll see here this last piece is the code for exactly what I just told that tool to do. And so what I'll usually do my first time through a process is I'll go in and I'll copy that, and I'll paste it. I'll keep it in OneNote. I'll keep it in a text document so that when I want to piece this together and do it in a semi-automated or automated fashion, it's there and it's easy for me to work with. It's easy to put those pieces together. One of the other ways that you can work with this, especially if you have multiple layers that you may need to clip to get that extract, is to build a model. And so usually it's really common with roads and address points. We have a provisioning boundary. We want to clip both. We're going to have outputs, and we want to save those outputs. And so it's easy to do this, to build out that graphic design. You could always validate and run it from here if you wanted to, but it's also important to note that there's code behind the models that you build, and so if you design it here and save it, then you can also go in and copy that stuff that it used to run that model, and paste that and kind of save that for how you can turn it into a more automated model in the future. I'm going to go and clear that out so I don't accidentally run that, but that's something that's pretty easy to do. All right. So now I have the extract of my road center lines, and so now what I want to do is start thinking about how well this data compares to what I need to get it into in the NG9-1-1 GIS data model compatible schema. That's where I'm going to need to do transformation work. This data is currently used by localities. It's based on fields and field names and types that they have to make other softwares and processes work. There are some similarities there to the NENA data model, but not a lot. And so one of the things that I encourage doing as part of this process is doing your homework. If you're not familiar with the data model, I made a spreadsheet. I kind of gone in and copied out the address point and road center line schema, and kind of go through and do a review. What does the data model need? What may I need to do in my data? What can I field map? What can I plug in there? What am I going to need to calculate to have an idea of knowing if, well, might I just be better off adding a couple fields to my data and populating it? Or am I really going to need to shove it into a template data to make it work for the process? So for our purposes here, what we're going to show is using one of the NENA GIS data model tools. You have the data model document here. Now I'm going to go ahead and copy and paste this link in the chat if you're not familiar with where this is. So there's the data model document, but there was also a work group that built out a template, both the geodatabase and then as a SQL table, everything that's in the GIS data model. And so if you want a target to program against or aim for, or something to shove your data into, this is a really good tool, and it also already has built out some of those quality assurance, quality control methods that Jeff talked about. There's some domains that are already built. You can tweak some of the other domains to really hone in and make sure it's making sure the data that you send into it works out well. And so how I have this set up is I pulled down the geodatabase from that NENA data model. This locality's data is in Virginia State Plain Harn, NAD 1983. And so when I built this out, I went ahead and made that Harn for the spatial coordinates. And I have the different data sets in here: address points, road center lines, then law, fire, and EMS emergency service boundaries. And if we look at them over here, I'm going to close the attribute table. This is just an empty schema. There's nothing in here right now. But our goal in using this is going to be to take the data that we have in this clip of our local data and copy, push, transform, load those features into this empty feature class. And use some of the tools possible to field map data over if it's not in the exact named field. And then we're going to go back, we're going to check our work, and then we'll look at some of the things that we need to populate for the data model that aren't in there. So that is our roadmap ahead. So in terms of loading data into a target, and it's usually easier, I find, to have an empty geo database here. And what I'm going to do is I'm going to turn my roads clip off and kind of have this on here. Is to use another one of those really common geospatial tools, append. We have data in one data set. We want to put it into another data set. One of the things I recommend is that if you use this method, I'll come back to that at the end. It'll make a little bit more sense there. But what I want to do is I want to take my roads clip because that has the spatial extent. I want to load that into my target schema road centerlines feature class. And then I know that my input fields don't match the target fields. And so here's where we need to do some work, but there is a field map to reconcile field differences option that's here. And so what this shows us is in red are, well, in this column, the output fields are all of the fields in our target data set. In some cases, it finds something based on the field name that it matches and it can map to, like ESN left and ESN right. But for most of the rest of these, one way it matches, even if I know that there's data in my local data model, the field names are so different, it's not going to help me out there. But we can use this tool to say, hey, shove the data from this column into this column when we do the append. This locality's data is a particularly good example of this because it's a shapefile. And we know that if our column names are really long, that shapefiles truncate them, and we kind of get with the abbreviations. So that's something that we'll have to deal with. So discrepancy agency ID is required by the NENA data model. I know I don't have anything in my existing local data to populate that, so that's one that we'll have to come back later and look at and clean up after we do the append. But I know for effective date, I know I have an attribute date that I have a business process to update. So I'll set this so when we append this data, what's in the attribute date will go over into the effective date. Let's see, what are some other ones I know that I have? Talking about road center lines, almost everybody has from and to addresses on the left and right. Everybody calls them something different in their local data. So I can go ahead and through the menu here and select and pick those. So that's going to be left high for left, so left low for from address low, left high for to address low. Similar thing for addresses, right low and right high. There we go. Parity, that's something we're going to have to clean up on the back end. There isn't anything in the local data to work with for that. But street pre-modifier, no, there isn't a street pre-mod in this. There is a street pre-directional. So as I'm going through this, if you're not familiar with the NENA data model, one of the other things that the URISA NG9-1-1 task force worked on was a geospatial fact sheet that kind of introduces the data model and some of the things to be aware of or to get you up to speed with what's in that data model standard and how they talk about things. And that is on the URISA's website. In a couple of different places, linked to in a couple of different places. Thanks, Wendy, for posting that link in there. That can help you get up to speed with what some of these things are. I'm trying not to go into a lot of detail with them, just so we can get through the example here. But there are some other really good sources out there if you're not familiar with the data model. Post-directional, there isn't a post-modifier. I think I'm going to skip for time the legacy street name types, MSAG community, we need that, but that is required. So I had a question pop up direct to me. I'm going to read it and then go back to my clicking. Does any city you know of use a coordinate system that is not HARN for E9-1-1? Actually, most Virginia localities actually use, keep their local data in NAT83 state plane and don't use the HARN variant. We have some folks that use the HARN variant in their local operations. In Virginia, we're a Commonwealth. It's locality choice. Everything's a locality choice. But for the next generation 911 requirements, as Jeff kind of touched on, it does require a WGS 84. And so how Virginia is approaching the project, we know that when we use our vendor for that's providing the spatial interface, when our localities upload, it converts that to WGS 84. And we've done quite a bit of testing with that. We're pretty comfortable with how that works, how that's going to handle. But it's definitely something where somewhere along the line, that transformation usually needs to get done from local coordinates to WGS 84. And so it's something that, you know, we definitely recommend talking with who you're working with, providing that spatial interface to do that. All right. So I've gone through and kind of field mapped most of the different data layers that we need and columns that we want over in that data. And so when we go ahead and run the append, what it's going to do is take all those features in that clip data set, load them into this target data set. You can see how those appeared there on the screen. If we go and we look at these attributes now, we see that this table miraculously filled itself out. And some of those different things like from and to addresses are in there. They're carried over. They mapped them in how we wanted them to, as well as the different field name pieces, pre-directionals, street names, post types. So that worked just like we wanted it to do. Similar to the clip, since we ran it, we can go ahead and look at the code of that. And I definitely recommend running it through the tool first and having the tool generate the code. You can always go in, delete your rows and redo it and tweak it if you want to do it. But using the GUI tool to create the code really sets you up for helping you automate it a little bit later. So that's what the code for that append looks like, where you can go through and you can kind of see the source, the target, and what field maps to where. So our next step is that to fill out this target, to try to get it ready to load some other stuff, we know we're missing some key attributes. And so normally, if you're not going to add those onto your local source data, we probably want to go ahead and calculate the fields where we can. Discrepancy agency ID is an easy one because it's going to be consistent, usually probably consistent for all of your records. And so it's really easy to go in and put that in there. You know, we're going to pretend that this is a registered domain name. And that's what our sample Virginia locality uses, sample.va.us. And so that populates that, so it meets the data model. The NENA GUI road centerline NENA global unique ID is another one that we can usually do. We didn't have, for better or for worse, it's just not there, a local unique identifier in the source data. So that's something else that we can normally put in here and help automate as we are plugging this in and populating this and trying to make sure that it works for what we're going to upload. Get my format there. And so we can go through and we can do that, have that populated there for the other things that we need to fill in. Similarly, we can go ahead and save those little pieces of code because that's something that we can string together. As you go through and you're planning that and populating what you need to populate, that provides an easy way to document that and build that as you work through your data model plan. So we clip, we append, we loaded that into the target, we go through, we field calculate the things that we need to piece in. We could do that manually each time. There's a lot of stuff there. In ETL processes, if you're loading it to a new system, it's important to do everything the same way every time. And so doing models or doing the semi-automated process is a way to help that out, especially with the what we do with our ESZ layer to create our LawFire and EMS. There's a union step, there's a clip step, and then we have to do some append stuff steps in there. But what I would like to do is kind of skip ahead, and what I'm going to do is kind of reset the process. What we tend to do is if we're working with target stuff, kind of have that as a geodatabase, and then go through before we run a cycle, go in and there we go. That's what I want to do. Go through, clear out those targets. If we're going to do this semi-automated or do this automated, if we're doing appends, best practice is to have a step where we go out and clear those out. That's going to run for a second. Our roads are going to disappear. The other things that we may have there may disappear as well. But what I'm going to do is show you what it looks like if we took all those steps. And so here I copied that code for the model to clip address points and road center lines. And I have in here a little bit of the model that I showed there to work with our ESZ data and turn that into ESBs. We have some, we're going to make sure that we deleted the rows we're appending into. Then we are going to append those data sets and calculate those. So here you can see the code for the append. I ran the tool, I copied it, I pasted it. Here's the code for road center lines append that we just looked at. This is what I prepared yesterday. Then we get into our address points and road center lines. There are going to be some other fields we want to go back and calculate to help prepare it for that load. And here's some code for the appending the ESBs and some calculate that we need to do there. So all that stuff, if you want to run it semi-automated, you tweak that code, you have it where it works well. You can paste it in there, and you can run that. And it will start, I left the history window up there so we can kind of see it's going to cycle through those. We started about 354.31. What I'm going to do is I'm going to flip back to the slides as that runs. So one of the things we urge you to think about is don't think about ETL as a set process. Think about it as pulling different tools that meet different business needs that you have, depending on your data and depending on what your goals are. If you're extracting, those can be spatial processes, those can be attribute processes. A lot of transforms, the common tools are what we think about geoprocessing or table joins or splits. You can really get into there with the attributes. And then loading, we're normally looking at a load or append. If you're loading actually into a spatial interface, what we're going to do at the end is take our geodatabase, zip it up, put a date on the end of that file name so we can keep a copy of that we uploaded it, and then that's how that actually gets up there. But sometimes we need to calculate some fields after we do that. The metaphor I like to use is that ETL is the set of tools in your toolboxes. And if you're planning in building a treehouse or you're planning in building skyscrapers, some of those tools are the same. There are definitely more tools and more advantages and more in the weeds stuff that you can do if you're building a skyscraper, but a lot of those same common tools are still there. A clip is a clip, append is append, calculate a field is calculate a field. And that's really not going to change too much as you're working on these different processes. So there we are. That's perfect timing. So we started the process at 3:55. Nope. 3:54:31. The last process ended at 3:56:31. So about 2 minutes. It took through and did all of that that homework that we did. Created these clip layers and in between layers, and we go and look at this with what's left, just with what's in that that target schema. We have our address points. We have our this one. Yep. So we have our address points. We have our road center lines. We have our law, fire, and EMS boundaries that we've taken that extract out, we've transformed it, we've loaded it, we've appended and field calculated, all those different fields that need to be done. So to me, that's kind of semi-automated. I work through the steps, I know what the code's doing, I copied the code, but I'm still pulling up the software, pasting that in and running it. Fully automating that, to me, would be taking the step of pulling it out and arranging the code so I could just run a batch file and schedule it to run at 2 a.m. and not even have to open up the software. I'd come in the morning, look at the log file, look at the results, made sure it was all there, and then zip that up and send that on. So that to me is kind of the difference between semi-automated and automated. Either way, if you have code, if you're relying on code, you're kind of ensuring that all your steps are being done the same way each time, which if you're building the more complex things you're building becomes more important. So that's our demonstration of extract, transform, and load, starting mostly with road center lines and getting into some other fun stuff. I hope the fact that whole thing that we talked through and going through the interactive and using the tools for 15 minutes, 20 minutes, and then we run that for 5 different layers in 2 minutes, really helps demonstrate one of the advantages of the more semi-automated or automated processes. Just a reminder that there are quite a few different resources up there, including probably the recording of this webinar up on our URISA NextGen 9-1-1 Task Force website. All right. So I did see a question come in from Ed Wells. Thank you, Ed, for your question. Does the NENA GIS Data Model provide for ETL of the geometry elements and topology rules of a centerline file? For the ETL of the geometry elements. The data model itself for the row, let me think through that. I don't think that part of the data model really deals with line topology in kind of like a network sense. I think that's kind of what you'd be getting at geometry topology wise. Generally what we see folks doing is that you have to follow the topology rules of the provisioning boundary that you have to work within, but I don't recall anything native to the data model that really structures those topological relationships. Jeff, can you help me out on that? Do you recall anything in the data model?
I think you're 100% right. They kind of, to my understanding, left that out because the different vendors handle those topologies differently. and have different requirements and needs around where boundaries come together or where roads and boundaries begin to overlap. So that, I think you're right.
All right, excellent. So Chase, thanks for adding your comment about some of the other ways to do ETL. You know, you can use FME or some of those other products. And yeah, if I was taking the semi-automated process and doing a fully automated process, and wanted to loop in more of the native Python, you know, zipping up the geodatabase is probably something that I do. It kind of gets back to the point of, you know, there is no one single right way to ETL. There are a lot of tools in that toolbox that you can pull out. We recommend, if you're getting started with this, or if you're using this as a gateway to coding or programming or Python within your GIS or other coding language, use what you're comfortable with. That way you kind of have an understanding of what the tool should do, and it kind of helps you out learn those things. And then it always provides ways to add on to where you can do more with it. Marianne asked a great question, suggestions for how to manage the various components of street addresses, especially from an automation standpoint. So maybe the local data that we start with has everything in one field, but we need to break it out when we try to load it or transform it to the NENA data model. There are ways to automate in doing that. It really depends on how uniform your data is with that. But there's Python code that you can run within your GIS software, or even doing it in native Python to separate and split out things that are, you know, if it's a pre-direction and that's the first character, you can peel that off and that value off and put it in its own field, and you can kind of slice and dice up the data that way. Definitely a little bit more difficult and complicated than some of the things that we've looked at today, but there is definite code samples in the Esri website and other folks on the Python side of things that can help you do that. If you're more familiar with Excel, sometimes it's easier to export that attribute data to Excel if you have a unique identifier in your data. Some folks are more comfortable doing that cleanup there. And then you could add those fields to hold those breakout parts in your local data set, which would make the append into a target data set easier, or maybe means you don't need to do that append. So that's a great question, because sometimes the strategies for how you work with your data, sometimes it's not GIS software. You know, sometimes you might be more comfortable doing it in different programming language. Sometimes Excel or a text editor can help you out and do it if you want to do that. We are working on some code samples for that in Virginia. If you'd like to see our thoughts on those when we get those done, feel free to shoot me an email, Marianne, and I'd be happy to provide those.
And I would just make one comment on that it's always easier in an automated ETL process to go from more granular to less granular than it is to go from less granular to more granular. So what I like to recommend where possible is that you maintain things in the very granular format that the CLDXF and thereby the NENA GIS data model requires things. And then if you have an output that requires things at a less granular level, it's very easy to append those things together through script versus the more challenging effort that it is to parse and break down, as Matt well described.
Yeah, that's an excellent point. Sometimes projects like this, the work that you do doesn't necessarily help you with your ETL and that target data set schema that you're trying to match. sometimes it lets you know that you might have to do more housekeeping on your local data itself. That would not only make the ETL for, say, NextGen 9-1-1 easier, but would also probably open up opportunities and advantages for other challenges and situations that you may have. I agree that it's not completely automatable unless your data is extremely standardized and uniform.
Yep.
You are probably talking about a looping through and cleaning it up in several runs process if you're trying to do that. All right, great questions, as I've come to expect from URISA events. So if you have other questions or things that come up, please reach out to me. Please reach out to Jeff if you have suggestions for other professional development that URISA can do, or professional development that the NG9-1-1 task force can do. Please share that with us. Let us know as well. We're happy to provide member benefits to URISA members, and so it's helpful for us to know what some of your needs are, or what you think might make good programming, especially on the next generation 911 side. So we are a little bit over, but Wendy, I do want to kick it over to you. Are there any other upcoming URISA events or deadlines or things that folks should be aware of?
Thanks, Matt. Great presentation, guys. Yeah, we've got lots of events coming up, including the URISA GIS Leadership Academy, which is back to being delivered in person. We'll be in Portland in August. We'll be in St. Pete, Florida in November, and Minneapolis in December. And the big one is URISA's 59th annual conference, which is GIS Pro 2021. We will be in Baltimore for that in first week of October. Again, that one will be in person, and there's a solid NG9-1-1 and addressing track already on the schedule. The program should debut later on this week, I believe. And we've also got another addressing and NG9-1-1 summit that will occur. It's in the planning stages right now, but it'll be the first week of February 2022, and it will be presented virtually. So we've got tons of content coming your way, so please stay involved.
All right. Thank you, Wendy. Thank you, everyone. And thank you for spending a little bit of your Tuesday afternoon with us, and catch you all down the road.
Thanks, everybody. Bye-bye.
Thanks.